are going to discuss the protection against free radicals, that is with the help of the antioxidants, where these antioxidants interact with the free radicals and neutralizes the free radicals, thus preventing them from causing any damage. So here, before the free radical act upon any biomolecular structure element, they before to that, these particular antioxidants will be readily affect the free radicals which is freely available within the biological system. So here what will happen, this is going to prevent the damage before the damage is going to happen. So further, many antioxidants work by transiently becoming radicals themselves. So in the sense that these antioxidants, they are going to be in the form of the stable molecules only, but when their function is has to be performed, they are going to act as the free radicals, in the sense they are going to either readily accept the electron present in the free radical, that is the oxygenated free radical, or they are going to donate their electron to the free radical molecule. So the free radical molecule which is highly reactive and can damage the biomolecular structure with element, so that can be avoided. So even after the reaction, this particular antioxidants are going to be present as the stable free radicals, and the free radicals is already got neutralized. In the same manner, when you are going to consider these antioxidants, they are going to present in two kinds, that is endogenous, that is within the body of the organism, exogenous, where the organism is going to intake the antioxidants through its nutrient. Now here, antioxidants are also known as free radical scavengers. Scavengers in the sense they are going to readily affect the free radicals, oxidant free radicals present within the body or the cell or the tissue or in the body environment, and they are going to clean those free radicals action, and further they are going to make them stable. So further they should not make any homeostatic distress, they should not create any homeostatic distress. The body makes some of the endogenous oxidants that it uses to neutralize free radicals that we have spoken. These antioxidants molecules are present in all life forms. So here, when you are going to consider the endogenous form of the antioxidants, they are present in all life forms from bacteria to mammals, indicating their appearance early in the history of life. So as the life has got existed, these endogenous antioxidants has got appeared. That is what the meaning. Now when you are going to consider this, how this antioxidant is going to work, when you are going to consider this diagram, under this the damaging free radical will be present like this, where electron has to be transferred either by donating or accepting, that is the free radical. Under this, when you are going to subject the antioxidant, here is the antioxidant which is already stable with its octet, that is 1 2 3 4 5 6 7 8 electrons in its outer orbit is already present, and here it is going to reduce itself by donating a electron to the free radical which is already in the excited or highly reactive state. So here what is happening here, after donating, this free radical forms a stable radical, neutralized free radical. Now this particular antioxidant is going to get converted to a stable free radical. It is not unstable highly reactive free radical, it is a stable free radical. Now when you are going to consider, this is the mechanism how it is going to work. Certainly in some cases even the free radicals are going to react with the antioxidants, where both the molecules are going to keep attached, and they can become a dipolar or dimagnetic kind of the molecules. So here, when you are going to consider the further diagram, as we have discussed here, two kinds of antioxidants are present. One is the endogenous, other is the exogenous antioxidant. Here you can see the antioxidants which are endogenous, they are going to be like enzymatic and non-enzymatic. Non-enzymatic in the sense within the body itself it will be circulated, that is glutathione, thyroredoxin, ubiquinone, uric acid, lipoic acid, and bilirubin. Definitely, they can act as the non-enzymatic kind of the endogenous antioxidants at an appropriate threshold concentration gradient required kind of the production. If even these are going to increase in high number, definitely it is going to lead to the different medical symptoms. But here at the optimum threshold production, they are definitely acting to be as the one of the scavengers or the endogenous antioxidants. The other enzymatic, that is the catalase, superoxide dismutase, glutathione peroxidase. So all these three is the major form of the endogenous antioxidant, where this endogenous antioxidants are always readily available in the cells of the organism. So this is regarding the endogenous antioxidant. Further is the exogenous antioxidant. These are one which we are going to take through our nutrients. So here vitamin C, A, E, K are the four antioxidants, and beta carotene, ubiquinone, polyphenols. Under these polyphenols, phenolic acids, flavonoids. In the flavonoids, you can see so many types. Quercetin is one of the major which we are taking, and it has the high efficiency of scavenging the free radical when compared to C, vitamin A, C and E and K. Vitamin C is having the high range of the scavenging of the free radical, whereas quercetin is also going to fall under the same. Where the in flavonoids, the first important or prime antioxidant is the quercetin. Whereas you can see the names like flavonols, flavones, flavonols, flavonones, isoflavones, and anthocyanin, and also there is the resveratrol and curcumin. So these are the few exogenous, very prominent and very important kind of the antioxidants which are studied in the medical field, where they have the potential to highly rectify the presence of the free radical within the biological system. Now, so here these act as the protection against these free radicals. So here, these antioxidants readily act to neutralize and stabilize the oxidant free radicals. Further, coming to the next slide, enzymatic antioxidants. Here you can see the function of the superoxide dismutase, catalase, glutathione peroxidase, and further. Here you can see that enzyme, this SOD, superoxide dismutases called to be as the enzyme that catalyzes the conversion of two superoxides into hydrogen peroxide, you can see, and oxygen. The benefit here is that hydrogen peroxide is substantially less toxic than superoxide. Compared to the superoxide, the hydrogen peroxide radical is less toxic. So the superoxide dismutase converts the superoxide to hydrogen peroxide, and here further superoxide dismutase accelerates this detoxifying reaction roughly 10,000 fold over the non-catalyzed reaction. Here, the meaning is that there is certain non-catalyzed reaction where there will be the formation of the superoxide to the hydrogen peroxide, but compared to the reaction frequency, the frequency of the superoxide dismutase enzyme, where it is going to catalyze the reaction at the 10,000 fold compared to the non-catalyzing form, where there is no action of the enzyme. So here further is superoxide dismutase are metal containing enzymes that depend on a bound manganese, copper or zinc for their antioxidant activity. In mammals, the manganese containing enzyme is most abundant in mitochondria, while the enzyme or copper forms predominant in cytoplasm. Interestingly, superoxide dismutases are inducible enzymes. Exposure of bacteria or vertebrate cells to higher concentrations of oxygen results in rapid increase in the concentration of superoxide dismutase. Now here you have come across the very prominent role of this superoxide dismutase, where if there is any infection by the bacteria or the pathogen, or any oxygen resulted form of the reaction happens, and there is the formation of the superoxides. So here we have already spoken about the macrophage or the phagocytosis, where there will be the action of the bacteria, and due to that there will be the reaction of or the production of the oxygen species, reactive oxygen species. So here what will happen during those times, what will happen, this particular superoxide dismutase is going to be secreted or the on the high amount, and the concentration is going to increase in that particular location to neutralize the whatever the free radicals are going to form. So this is what the action of the superoxide dismutase. Next is the catalase. Catalase is found in peroxisomes in eukaryotic cells. It degrades hydrogen peroxide to water. Now the overall thing is has been solved, and water and oxygen, and hence finishes the detoxification reaction started by SOD. So it is a cycle of reaction. So further is glutathione peroxidase is a group of enzymes, the most abundant of which contain selenium. These enzymes, like catalase, degrade hydrogen peroxide. Even this is going to catalyze the hydrogen peroxide. They also reduce organic peroxides to alcohol. So when they are going to catalyze the hydrogen peroxide to water or the alcohol, here this is going to be one of the finest form to detoxify the particular cell or the tissue, and this can be easily removed from the body of the organism. In addition to these enzymes, glutathione transferase, ceruloplasmin, hemoxygenase, and possibly several other enzymes may participate in enzymatic control of oxygen radicals and their products. Now, what we have discussed about the superoxide dismutase, catalase, glutathione peroxidase, this we have already discussed during the source of the production of the free radicals. Let we see that slide also, so that you can understand the interaction of this particular explanation. Now here you can see that in this reaction we have spoken about the action of the superoxide dismutase, where the superoxide will be converted to hydrogen peroxide. Okay, and also we have spoken about the electron transport chain. Here you can see in this diagram where there will be the formation of the superoxide, where this superoxide at the coenzyme Q. So here what will happen, this superoxide will be going to come under the magnesium superoxide dismutase. We have discussed this manganese presence of the in the superoxide dismutase now itself in the slide of antioxidants, endogenous antioxidants, where it is going to react this particular superoxide and reduce it to or form it into the or convert it to the H2O2, whereas further this will be reduced to OH in the presence of the metal ion, in the sense that H2O2 is going to get converted to reduce to the OH in the presence of the Fe2, which we have discussed during the oxygen abundant superoxide free radical formation. And also we can see here in this diagram the catalase, which reduces the H2O2 to water and oxygen. You can see catalase H2O2 to, and here glutathione, which is going to reduce this into the water. Here you can see in this also you can see that there is the formation of the non-catalyzed form of the superoxide to the hydrogen peroxide here, where this has been taken into consideration by the glutathione reductase, and it is going to reduce this to the water, and it is going to subject it to the NOx. That is the NOx is again the Fox reaction, which we have already spoken, so here we no need to discuss that. So here this is what, so NaH2O2. Now here glutathione reductase is going to take part in the reduction of the H2O2 into water. You can see here. Now further endo or exogenous toxins or compounds has been recycled or safe compounds. So this is what we have discussed in this enzymatic antioxidants. These are the three group of enzymes. Now here again in this diagram you can see that these are the free radicals, and this is the endogenous sources of the free radical formation. Okay, and here this is the antioxidant defense, which is going to act here, like the catalase, SOD, superoxide dismutase, glutathione, and non-enzymatic systems like glutathione, vitamins A, C, and E. Now here this is going to reduce this, and exogenous sources like the ultraviolet light, ionizing radiation, and these are going to cause this formation of this. Now here all these are going to create a hemostasis. Actually in this flowchart, as there are the free radicals here and the arrow marks has been respectively placed like the straight one, diagonal, and diagonal. Here if the antioxidants are going to act on these free radicals, the homeostasis is going to be normal growth and the metabolism will be normal. So if there is the exogenous sources here, they are going to generate the free radicals and the effect will be less, but the impaired physiological functions will take place and decrease proliferation response, defective host defenses will be seen. Now here when you are going to consider the endogenous sources, the homeostasis is going to be having more impaired physiological functions, that is the random cellular damage, specific signaling pathway is going to be seen, where the damage will be seen in that, and aging, disease, and cell deaths will be seen. So this is what regarding this particular picture depiction. So we will go to the next slide. Non-enzymatic antioxidants. These are also three non-enzymatic antioxidants. So here it is the vitamin E, vitamin C, and glutathione. Here the glutathione transfer, peroxidase or the glutathione transferase, which we have spoken here, and glutathione peroxidase are different from this one. This one is the nutrient which we are going to intake. Here this is the synthesized form of the enzymes. Now here vitamin E is the major lipid soluble antioxidant and plays a vital role in protecting membranes from oxidative damage. Its primary activity is to trap peroxy radicals in cellular membranes. Further, vitamin C or ascorbic acid is a water-soluble antioxidant that can reduce radicals from a variety of sources. It also appears to participate in recycling vitamin E radicals. Interestingly, vitamin C also functions as pro-oxidant under certain circumstances. Both functions as the pro-oxidant in the free radical scavenging, whereas vitamin C is going to recycle the free radical formed by the vitamin E. Vitamin E is the one of the antioxidant which is going to trap or scavenge the peroxy radicals specifically. And here, whereas the glutathione may well be the most important intracellular defense against damage by reactive oxygen species. It is the tripeptide glutamyl cysteine glycine. The cysteine provides an exposed free sulfhydryl group that is very reactive, providing an abundant target for radical attack. Reaction with radicals oxidizes glutathione, but the reduced form is regenerated in a redox cycle involving glutathione reductase and electron acceptor NADPH. Now here, when this particular glutathione is going to react with the free radical and it is going to scavenge. After getting scavenged, whatever the reduced glutathione or oxidized glutathione will be present, it has to be recycled with the help of the NADPH electron acceptor and also the glutathione reductase. So here this is water, and now here you can see this particular diagram where there will be the production of a formation of the free radicals which act here, and there will be the reduction or the action of the antioxidant enzymes which are endogenous, and it will be neutralized. Further, if there is no endogenous action due to the high abundant formation of the free radical, then it will be this the free radical is going to get into the contact with the either the vitamin E, vitamin C and glutathione. They are going to take part in this action. Whereas if there is the any peroxide radicals, the vitamin E is going to take part in its action, and after the action of the vitamin E chromonoxyl radical will be formed where it is going to reduce to this and it will be recycled by the vitamin C. So here as the ascorbyl radical, further the glutathione is going to reduce the ascorbyl radical and it is going to what called neutralize the free radical. Like this, the cycle is going to take part. So here certainly individually these vitamin E, C and glutathione, they can trap the free radicals, and also their phenomenal form also they are going to show this particular cycle. So here I have spoken very brief amount of the features about this particular enzymatic and non-enzymatic form of the antioxidants. If you have any doubts or anywhere I have missed or I have given any wrong information, please mention in the comments so that I can rectify. And this completes these slides, and I hope I have provided much which is required during the explanation of the topics.